Hello, my name is Minju Na, and I'm majoring in bioinformatics at the KAIST in South Korea. I'll be giving a presentation on the AOP Network Box, which is research on integrating AOP and biological data to bridge the information gap by connecting the network. First, let's explain what an adverse outcome pathway, AOP for short, is. A biological map depicting the mechanism from the molecular level to the final adverse event that can be observed at the individual level. It starts with a single MI and goes through a series of key events to arrive at the final adverse outcome event. Let's briefly describe each MIE, KE, and AO. Molecular initiating event, MIE for short, is a direct interaction between a stressor and a molecular target. A key event, KE for short, is a measurable biological change at the molecular, cellular, or tissue level. An adverse outcome, AO for short, is a biological change that is considered relevant to risk assessment or regulatory decision-making. You can easily assess the connections to MI, keys, AO, and the details of each AOP. However, viewing multiple AOPs from a network perspective and analyzing the AOs derived from the connections between keys takes work. Furthermore, the MIEs of AOPs can be described by proteins and keys by GOs, suggesting that AOPs can be connected to biological networks, such as PPI, GO, or DO. Therefore, this study aims to integrate and bridge the gap between AOPs and biological data by collecting all known AOPs to build on AOP networks and link each biological events. Let me explain how to build an AOP network. We used the January 1st, 2024 version of the AOP Wiki with 468 AOPs and pre-processed them according to the following three criteria. The result is 304 AOPs and 1,274 unique ID events. The visualization of the built AOP network is shown on the right. We utilized Stitch database and a predictive AI bind model to score whether and how much chemicals interact with proteins. We connected the AOPs to the biological network by leveraging UniProt KB to link proteins and GOs and matching each piece of information to the AOP network. The AOP Network Box algorithm is as follows. When the user inputs SMILES information and presses the Submit button, the protein ligand score is obtained through Stitch database and AI bind prediction. The AI bind model prediction part was written in Python, and the web server and AOP Network Box modules were written in R. Here's full validation. In here, total connection corresponds to the combination of number of AOP biological events by number of proteins that the chemical is associated with, and target-related corresponds to the number of AOP biological events that the chemical is associated with the androgen receptor, AR for short. The chemical protein association is labeled without prediction when only Stitch was used, and with prediction when both Stitch and AI bind prediction models were used. When all ligands are with prediction, the total connections are significantly increased and more AOP biological events related to androgen receptors are presented. In particular, in the case of Arctic acid, no relationship with the androgen receptor could be found when only the exiting public debit was used, but a relationship could be seen when the AOP network box was used. Let me introduce about AOP Network Box Web. Users enter SMILE's information into a web server and select the interaction score, number of interactors, ontology, and p-value adjustment method, and then the prediction and analysis results for 6 categories are displayed on the web. Users can view or download the results online, and the AOP network box is free. In summary, we constructed an AOP network by connecting and pre-processing AOPs and developed a web tool for integrated analysis by linking biological networks to the AOP network using public database. By integrating AOP and biological networks, we aim to bridge the information gap and developed a web server-based tool for predicting and analyzing chemicals, proteins, GOs, and processes leading to adverse outcomes.